Now let's move on. Let's see what are the other public functions that I've created in this program, in this class. So before we go ahead, I want to point out that it's important to declare these constructors and destructors as public. Now suppose, think about what happens when you create these member functions as private. What happens is that you cannot then create new objects from outside the class. You are only allowed to create objects from inside the class. There are situations where we will do this, but in most cases we want to provide the ability to create objects and destroy objects from outside the class, so it's important to make these member functions public. Now the other public member functions that will be part of any class are some getters and setters. So these methods will be used to get an access to our member variable. So if we want to read what is the current state of a member variable, we can use the get method. Or if we want to set a new state for our member variable, we can use the set method. So for example, first we will see how to declare and define a member function within the class. Then we will see how to declare the member function within the class and define it outside. So in line 84, I'm showing you how to declare a get method. So here the name of the function is get_name. All it will do is return the name of our employee. Now we can use this pointer to explicitly say that the name belongs to the object which is pointed to by this pointer, or we can just ignore the syntax this and write just return name. Both of them will return the same name. However, one of them is just making it explicit that we are using the object that is pointed to by this pointer to access the member variable name and returning it back. Now, since this member function is only reading our data members, it is not modifying any data members, we can additionally make this member function a constant. To do that, you can first declare the return type followed by a name, then within parentheses some parameters, and after that you can write const. So when you write const after the parameters, the compiler will make such functions as constant. Now constant member functions are only allowed to read and return the data members. They're not allowed to modify data members. Next, I'm creating another function called get_name. So get_name2, which is also returning name. The only difference is now it's not a constant function and it's returning a reference. So when we go to the main function, we will see what happens when we call the method get_name, what happens when we call get_name2, and why one of this is not recommended. Next, let's look at how to declare a member function within the class and define it outside the class. So the syntax is we are declaring a function called get_position in line 87. Its return type is string and it's a constant member function. Now to define this member function outside, the syntax is as follows. First you write the return type, then you provide the name for this member function, which is get_position. But before the name, you will have to provide a scope. Now the scope tells the compiler where this particular member function is declared. So since we have declared get_position within the employee class, the scope is employee. The colon operator is the scope operator, and employee is the name of the class in which this member function is declared. Again, we need to specify that this member function is constant since we declared it as a constant, and then body of the member function is just returning the position. So a good practice is to make your class declaration as simple as possible. So your class declaration should only have data members and declaration of member functions. The body of your member functions should be outside the class. Usually we put the definition within a header file, and then we will add the definitions. We'll move the definitions to a CPP file. Similarly, we have a function to get the location, get the pay rate, and contrary to that, we have member functions that can now set member variables. So set member variables usually don't return anything, so the return type is void. Name here is set_name, so obviously it should set a new name. So the parameter passed is also a name. We will use the pass parameter to set the data member name. Now a question is, can we make these set functions constant? So let's try first and see what happens. So we should get a compilation error, and that's what happened. So the compilation error says that we are trying to modify in a data member of our class within a const member function, which is not allowed. So if you want to modify any member variables of your class, then you can't make such member functions constant. Okay, so this was a lengthy introduction to creating a new class in C++. Now let's move on to the main function and get back to our employee management system. So first, let's look at how to create employees with our new employee class. What are the different ways of creating employees? That is, how to use copy constructor, how to use copy assignment, how to use default and parameterized constructor to construct new objects, and when will these objects be destroyed. So first, in line 172, I'm using the syntax that will call the parameterized constructor to construct a new employee E. So employee is now the data type, E is the variable name, and within braces I'm providing the values that will be used to initialize our new employee. So the new employee's name is Rick. He will be a chief scientist working in space and has a salary which is $500,000. Now in line 180, we are creating a new employee, this time using a default constructor. Before we go to 180, first let's check what happens when we try to print the name of the employee using directly the variable data member name. Notice data member name is declared as private, so this should give us a compilation error. The compilation error says that employee name cannot be accessed because it's private, so we are not allowed to directly access this name. So the answer to this question is that we should get a compilation error. Now let's move on. So in line 180, we are calling a default constructor to construct a new object, and we are storing it in the same variable E. The question now is, what will be the name? So if I use now the method get underscore name to get the name of our employee, will it be Rick? Will it crash? Will it not compile? Will it be an empty string, or will it be random? So these are your choices. So now the answer should be it's going to be empty. So since we have a default constructor, notice we are not initializing any of our member variables. By default, a string in C++ will be initialized with an empty string. So the name of our new employee E will be empty. So let's verify this by running the program now. Okay, now since we are printing when a constructor is called, we will see a lot of print statements. So first, let's go through these print statements. Notice first, employee E was constructed using a parameterized constructor. So we have this parameterized constructor was called. Then we have this default constructor called to create this temporary object on the right hand side of line 180. And then a copy assignment operator is called to copy this temporary object into this variable E. Notice copy assignment is called here because E is already constructed and is in memory. So E was constructed in line 172. And finally, a destructor was called to destroy this temporary object on the right hand side. The temporary object is no longer required once we assign it to the variable E. So the destructor is called. Now the name of the employee is empty. Therefore, we are not seeing anything printed on the terminal. We just see an empty line. Next, let's look at employee E1. Employee E1 has a name, position, salary, and all those things. Now in line 191, we are again using copy assignment to copy this employee E1 to E. So let's first look at what was called. So when E1 was created, the parameterized constructor was called. Now when we are calling E is equal to E1, notice only the copy assignment operator was called. So we don't have this extra default constructor being called and destroyed, since we are only using object E1, which was created before. And we don't need to destroy this object because we need employee E1 also. We'll be using it further in our program. So only a copy assignment was created. Now E will be equal to E1. Now suppose I write the statement E1.setName Tina, wherein I'm changing the name of the employee E1 from Bob to Tina. And the question is, what will be the name of the employee E? Will now employee E also become Tina? Will the name of the employee E be Rick? Will it still be Bob, or will it be something random? That's the question. Now the answer is employee E should still be Bob. Since we are using E1 to initialize E, name of E will be Bob. In the next line, we are only modifying the name of the object E1, and therefore only the object E1 will now be Tina and not object E. Okay, so let's continue and check what is the name printed. And the name of E is Bob. That's good. Next, we're creating a new employee E2. Again, we are using the parameterized constructor, but now the syntax is slightly different. We're not using braces, but we are using parentheses to pass the parameters. Both of them will do the same thing. So let's go to the main and hit continue. Now notice a parameterized constructor was called when we created E2. And now I'm using this method get underscore name 2 to get the reference of the name back in the main program. So I'm creating a local variable called name. It's a reference to string, and I'm using get underscore name 2 method to get the name of this employee and store it within this alias name. Okay. Now since E2 has name Tina, this will also be Tina. And now since I have a reference, I can write to this variable name. It's not a constant, therefore it's not read only, so we can modify it. So now suppose I change the name to Bob. The question is, what will be now the name of E2? Will it still be Tina, or will it be Bob? Or will it be something else like Gina? Now the answer to this question is hidden within this call. Since we are returning a reference to our member variable, name is just an alias to the name of this employee E2. Now if we use the alias to modify the content of the variable, we will also modify the content of our object E2. So now the name of our employee E2 should be Bob. So previously it was Tina, now it should be Bob. Now this is okay, so we answered the question. But what's important here is to notice that the name of our member variable was supposed to be private. That is, we were not supposed to provide access to our member variable and let it be modified directly from outside the class. To modify a member variable, we were supposed to use a set member function to change it. But since we wrote this member function get underscore name 2, and then here I'm supposing that by mistake I returned a reference, this allowed whoever is calling this function to modify the object without the class knowing that we are trying to modify it. So here the class is thinking that we are only using this method to get the name of an employee, but since it's returning a reference, it is used to also modify the name of the employee. So in your programs, don't declare get functions by returning a reference, always return by value, so that you only use the name that is written back to you and read it and not overwrite it.